All right, so as you're scrolling down through it, you should be able to do that stuff. You should be able to do this stuff. I do want you to cross out this page. Like, you could take a look at it, but page 28, cross out. And then the two questions that I want to do together, keep flipping. And we're going to do two questions from 5.6. And it's going to be questions 6 and 7. So what is that? Page 32. Turn to page 32. And as you're flipping, ideally, you're like, oh, I can do this, I can do this, I can do this. It's all pretty easy. But these two, a little strange. So I do want to do them together. And when we go through it, be very neat and organized with your the work that you show. So let me go ahead and get started. While traveling across a flat stretch of desert, Joey and Holly make note of a mountain peak in the distance that seems to be directly in front of them. They estimate the angle of elevation to the peak at 5 degrees. So they are standing right here, these two people, somewhere in the desert, and they just look straight up. They look straight up, and they tilt their head 5 degrees until they look at the top of this mountain. That right there is the top of the mountain. Then they are going to, they can't find anything with that information. They're like, oh, cool, I look up 5 degrees, there's the mountain. They can't really do anything with that. So then what they do, they walk forward 6 miles and do it again. Then they stand here and they look up, and I know it's kind of difficult to see, but they look up again, and this time they have to tilt their head 25 degrees to look at the top of the mountain. And now we want to figure out, how tall is this mountain? And I know it seems a little rudimentary, but like, this is how they do a lot of surveying. So there's a lot of survey equipment that you see on the side of the road as these different construction crews or road workers use. The programming behind it is a lot of trig like this. So let's go ahead and start off. And I could see a couple different triangles that are built. We're going to work with this overall triangle from when they first started. And we could see that we have this triangle. And the information that we have the angle closest to us. Even though we're missing some information, we have the adjacent leg. And even though we're missing this information, in fact, we're trying to find the distance, we are looking for the opposite leg. So think about the trig function that deals with opposite and adjacent. We also have this triangle. That is, when we walk closer, same thing. We have the angle inside, we have the adjacent leg, and the opposite leg. That's what we're looking for. All right, so throughout this, we're just going to set up a couple different trig functions. And it's going to happen in a roundabout way, but it will be how we can ultimately figure out what this value of d is, how tall the mountain is. So let's start with the overall triangle first. Now let's do the close one first. So if we do tangent of 25 degrees, and we're doing tangent because that one is the trig function that deals with opposite over adjacent. Tangent of this 25 will be the opposite distance, which is what we're looking for, over the adjacent, x. Unfortunately, we don't know what x is, so we can't just immediately solve it. But we have this other triangle, the overall triangle, where if we do tangent of 5 degrees, that will give us the same distance, because that's the same opposite leg, over the adjacent. And the adjacent in this case is everything. It's not just x, it's not 6, it's 6 plus x. So from here, I think I can isolate d and set them equal to one another. So I'm going to multiply both sides by, for this top one, both sides by x, and I'll get x tangent of 25 equals d. And then for the bottom one, I'll get 6 plus x tangent of 5 degrees equals d. And since they both equal d, I'm not trying to highlight that, I could set them equal to one another. X tangent of 25 equals 6 plus x tangent of 5 degrees. And I know it looks complicated, but I only have one missing variable. I only have x as my missing variable. So what I'm going to do, I'm going to plug this into my calculator, and then I'm going to solve, and I'll carry this down to the bottom part. So within your calculator, and if you don't have one, now would be a good time to grab one. I'm just going to type in, what is tangent of 25 degrees? And I get 0.47. So I have 0.47x on the left, and then I have 6 plus x times tangent of 5 is 0.09. 0.09. Well, that equation looks a lot easier. I do have to distribute this. So 0.47x equals 6 times 0.9. Sorry, 0.09 times 6 is 0.54 plus 0.09x. And now it's just looking like an equation that we have to solve. I'm going to subtract 0.09x from both sides, and I get 0.38x equals 0.54. Then divide both sides by 0.38, 0.38, and I finally get what x is. 0.54 divided by 0.38, which is 1.42. 1.42 miles. Unfortunately, that's not what we're looking for. We just found this, that this x is 1.42 miles. We're looking for the distance of the mountain, the height of the mountain. But this will lead us into it. So we're going to work with this equation because all we have to do is plug the x that we just found into here. So then we could do tangent of 25 equals d over 1.42. 1.42 times tangent of 25 degrees will give us what distance is, the height of the mountain. 1.42 times tangent of 25 degrees, and we get 0.66 miles, 0.66 miles. I'm going to pause the recording just if there are any questions within the classroom. A very rough and rudimentary way to double check our work is to think about the angles and the side lengths. So if this was 25 degrees, that means that this must be 65 degrees. Well, let's think about the sides that are opposite each of those. Opposite 65 degrees is 1.42. Opposite 25 degrees, the smaller angle should have the smaller side length, and it does. So that's just a very rough, rudimentary way. If this was something like 10 miles, that wouldn't make any sense because the smaller angle is supposed to have the smaller side. All right, so this is going to be very similar to how we approach number 7. And essentially what is going on, similar thing. We got this ranger station at Star Point. We have another ranger station at Twin Pines. There's a road that goes straight across, no turns, and it is 30 miles. Somewhere along that road, you make a right turn or a left turn, but it's a perpendicular turn, and you go down to Ben's hideout. There is a fire going on at Ben's hideout that these ranger stations want to investigate. So there's a fire going on, and the rangers at Starpoint can turn their head. Like right now, they're just looking at Twin Pines with their binoculars, being like, hey, what's going on? And then they turn their head 34 degrees, and they see Ben's hideout on fire. The Twin Pines people are with their binoculars looking at Star Point. They turn their head 14 degrees to see Ben's hideout. What we want to find out is after we make this turn, after we're driving and we make this turn, how far do we have to drive to get to Ben's hideout? So we're going to do the same thing. We're going to do the exact same thing, and it should help us find the answer. This is a little bit differently because this triangle is not broken up. So we can go ahead and make this X, but we don't want to make this Y, and you'll see Y in a second. So we could do tangent of 34, which means we're working with this angle, and that will give us the opposite, which is the distance we're looking for, over X. And we could also work with this triangle on the right and do tangent of 14 degrees, and that will give us the distance over, and instead of making this Y, and we don't want to do that because that just adds too many variables. But since I know the overall distance is 30 and this distance is X, that means that the adjacent for this triangle over here is 30 minus X. So then we're going to do the same thing. We got 30 minus X times tangent, don't forget the parentheses, of 14 degrees equals distance. And then for the top one, we have X times tangent of 34 degrees equals distance. Well, when we set those together, we just have to understand that tangent of 14 and tangent of 34 degrees, it's just a number. It's really nothing complicated. So tangent of 14 degrees is 0.25. 0.25. Tangent of 34 degrees is 0.67. So let's carry everything else down with it. 30 minus X equals 0.67X. I'm just going to rewrite that up here. 30 minus X times 0.25 equals 0.67X. Distribute out 0.25 times 30 is 7.5 minus 0.25X equals 0.67X. Add 0.25X to both sides, and we get 0.92X equals 7.5. Divide both sides by 0.92, and we get X equals 8.15. So we at least know that the distance from Star Point to the turn is 8.15 miles. And we don't need that information, but we could also even find the Twin Pines to the turn would be 30 minus that, so like 21.85 miles. Yeah. So now we can use that information, now that we have X, to find the distance of the road. And I'm going to use this equation just because it looks the cleanest and easiest. Tangent of 34 equals the distance over, not X, because we now know what X is, 8.15. 8.15 tan of 34 equals distance, 8.15, tangent 34 in my calculator, and I get 5.50 miles. 5.50 miles. That after they make the turn, that's how far they need to drive to get to Ben's hideout. Sweet. Excellent. I'm going to stop the video and then pause for any questions. Thank you.